Welcome to Making Stuff with Chris DeHut. In today's video, we're going to take a look at interfacing the Raspberry Pi PICO with a bar graph LED display. First, let's go over what we're going to cover in this video. We're going to discuss very briefly about what they are, the applications for them. There are several, and they're still used today. We'll take a look at a datasheet example. It's not the exact one for this project, but we can at least look at it and know where to look to get information that's helpful. We're going to look at a Fritzing wiring diagram for this specific display that I have here. Then we'll take a look at it on the breadboard so that you get that familiarity between the Fritzing diagram and the actual breadboard. And then we're going to take a look at three different ways we can utilize this bar graph display to communicate a message. We'll look at first just basically turning on the individual segments. Then we'll look at a VU meter example. And then finally, one of the more common ones we see today, a battery level indicator gauge. So with that, let's take a look at what a bar graph display looks like. Now these come in a variety of different numbers of segments. You can see them from 6, 8, 10. This one's 10. You'll see them up to 12, 16. I think I've even seen 20s, maybe even 24s. But luckily, they're often still in a dip package, so you can work with them on a breadboard. And each one of these LED segments is individually controlled, so we can set each one on however we want to. So we don't really need to use it in a sequential order as I'm showing here. Applications for these run the gamut. They've kind of lost favor in recent years because most people now are using LCD displays or OLED displays, etc., to show more information, perhaps in a more graphic method. But basic bar graph LED is still economical. You can pick them up for a couple of dollars, much cheaper than most OLEDs or LCD displays. And they do have a cool look about them, and you can get them in all different colors and so forth. So with that, applications that you'll see them used in are commonly a VU meter, which is a volume meter, often seen in audio recording equipment, perhaps a stereo system, etc. You will see them perhaps in software on a PC that is audio editing software, or any other device that requires showing the current level of power per se that's coming out of something or going into something. So for our example, we'll actually look at a VU meter example, source code, as well as a battery level meter. And you could use that fuel gauge concept across many different items. At the computer, you can see I've got a King Bright 10-segment bar graph array, or bar graph display. And the thing to understand about these, they're showing the different segments here, A through J, all 10 of them. And you're going to see the anode mark. One corner is usually chamfered. That's your indicator so you can figure out which is the anode and cathode sides, or positive and negative sides. They'll provide you with a PCB layout information, and then they're kind of showing the actual internal schematic. Basically, just an LED in all 10 positions. They're often multicolored, so you'll need to know a little bit about that in order to pick your resistor values. We'll just look at them here. We've got this covered very well in the simple LED or single LED video we've already put up on YouTube. Now the one that's on the system is mentioned. It doesn't have this exact same color coding. But what we do want to do is look at some of these optical characteristics or characteristics for what our forward voltage is. That's one that's really important, and it's different in this case. You'll see green and bright red have two different forward voltages. 2.0 for green, 2.05 for red. The more colors you have, the more you will get a variety for forward voltages, and typically you're running at about 10 milliamps. That would be your target current. As always, you'll see your absolute maximum ratings. This is not the ratings you would utilize to calculate your current limiting resistor, but they do show peak forward and DC forward current in milliamps. These are maximum ratings. That's why we would target 10 milliamps, not 25. Peak forward current would be something where you're flashing the LED only momentarily, and it might work or last, peaking it at 140 to 130 milliamps. And again, notice it's color specific. Here are your wavelength graphs. Forward current versus forward voltage. We were about 2 volts on each, so we're in this range on the graph. And that's pretty much a nice safe range. This was for green, and here is the same data in graph form for red. They're talking about bending the leads, etc. And then here's a circuit design, a schematic. They're saying we cannot use one resistor for all of the LEDs. We have to have it wired with one resistor per LED segment. So we have 10 segments in our example today, so I've got 10 resistors. Now, in truth, I cheated on my resistor values. I put them all at 220 ohms in hopes that I could dim down the display a little bit so that the camera would capture the colors, but I just simply cannot get the camera to pick up the colors. All I seem to get is just a bright white on it. In the real world, the colors are beautiful. So that's a quick look at a typical data sheet for a bar graph display. Moving on to the Fritzing diagram, this is a good schematic. It helps you to get a handle on what the wiring is for hooking up a bar graph display. We've got a ground wire coming out from the Pico up to a ground rail here. We've got all of our resistors plugged into that ground rail, and then they feed directly into the cathode side of the bar graph display. And as mentioned earlier, one corner will always be marked for pin number 1, or however they're going to reference it, so that you know which way to orient it. In essence, it's an LED. If you get it backwards, spin it 180, and it's probably going to work for you. This one resistor here looks kind of out of place. It doesn't line up with anything, but I've got a jumper coming over here to line up with this LED. As you can see, there isn't a hole here on the ground rails, so we had to put one over here and then run a jumper over. So that's the ground side of the circuit. And then from here, all these pins are connecting to each one of the individual segments as we go up the ladder here. So, for example, this one's going to pin number 1 on this particular display, and then pin number 2, and so forth on the display. No need for a resistor on this side. We've already got the current limiting resistor over here. Now, I would like to point out at this time, this is how you would work with a bar graph display being directly driven by the Raspberry Pi PICO. Oftentimes, you may not have 8 available IOs to drive a display like this, in which case we would use a driver chip in between the Pico and the bar graph display. In that situation, that driver would run off of either SPI or I2C, and we will be having a video in the future demonstrating that capability. Now let's transition into looking at the code for our first example, and that simply turns on all the LED segments on in sequence, and then turns them off in that same sequence. As we can see here on the breadboard, we start out, my first one comes on, that's blue, goes all the way to the top to red. Then it'll turn them off in that same order. Now again, just as a reminder, this second to the top LED is broken because of a boo-boo by me. Now let's take a look in the code of how that's done. The comments at the top will kind of give you an idea of the wiring, what are the requirements, the type of bar graph segment, etc. We're going to load in the machine library, which allows us to use pins for I/O, the micro time library, which allows us to create sleep and dwells, etc. Each of the segments is referenced in the datasheet by a letter, A through J. In this case, we've got 10 LED segments, and each one's assigned to a pin on the Raspberry Pi PICO. This is not the physical pin number, but the GPIO pin number. So we just simply create an LED object, A LED, B LED, C LED, etc. For each pin, and then we assign it as an output. And then we're going to go into my loop. I just simply do a print statement. We've got a little variable here, sequence delay of 0.1 seconds, and that allows the sequence to occur in an animated fashion as opposed to just simply turning them all on and turning them all off. But here's the workhorse. As I said, we're going to turn them on in sequence. We're going to turn on the A LED by setting its value to 1. That turns it on. Down below here, you'll see A LED value 0. That turns it off. So setting value to 1 on, value to 0 off. And then we're going to use our micro time sleep function and put in a short delay in between turning on each of the LEDs. And I've just done this in straight sequence here, inline code within our loop to do this operation. And this is more for you to just get an idea of what really needs to happen to turn each segment on and off. Back to the breadboard. Now you can see how that's going. And this would be my A LED, and this one would be my J LED up here at the top. From this code, you can create a number of different uses for a bar graph LED, depending on the colors it has, etc. You don't have to turn them on in sequence, as we've done here. That's just more for razzle-dazzle. You can turn on the individual segments however you want. Maybe you want to communicate a binary sequence with an 8-segment bar graph LED. Very cool stuff that you could do there. But for right now, why don't we take a look at the next example, which is to mimic a VU meter. A VU meter, you'll see in audio equipment, everything from equalizers to recording level meters for audio recording level, digital software like the video editing that I use, the audio editing software I use in the digital world. It has a VU meter to tell me what the amplification is or the level of the sound is. I've already got that program for the VU meter on the Raspberry Pi PICO, so I'm just going to call that up. And by the way, if you are working from the examples I'm providing, the way you would get your program examples in here, you can go to our website, the companion website. The link is down below. Download the files, and then you would open it in Thani, and then from here you could do a save as into the Raspberry Pi PICO. But we'll move through here. Our beginning is all pretty much the same. We're going to import a random function, and that's just to give us some random numbers to simulate various amplification levels of the sound, or the different sound levels that we would be displaying. We're going to start up or instantiate all of our LED objects so that we've got those. And then this is the animated display here. And I've done it in a function, and that way it's more efficient and more portable for you to utilize in your programs. Let's take a look at what this program will look like when it's running. Now, as you saw with my audio level meter that I showed you a moment ago, it moves very rapidly. It wants to show you the peak levels, and then it'll come back down. So this has to run very, very fast in order to do that. Probably in the neighborhood of 40, 50 times a second, 30 to 50 times a second, so that it's very responsive, showing you the exact moment in time what your peak levels are. But what I'm doing here is I am starting at the top, which is the J LED, and I'm checking to see if our peak value is at that high. If it is, I'm going to turn that on. If not, I'm going to turn that LED off. And then do the same thing going downhill. And that way, the lower values, which are commonly on all the time, stay persistent. They don't have to blink every time. Just as you're seeing, the blue one at the very bottom is almost always on, and then the second one up is on most of the time, etc. So this way of programming, it looks kind of awkward and cumbersome, but it really is giving you the visual effect that you want for a VU meter or any other meter that has to have fast response displays. So back into the code here, we're going to check our value that was provided, and that value would be 0 to 10. And we're going to look at it. If we're at or greater than 10, we will turn this LED on. Remember, this is the top one, the J LED. We'll sleep for a very, very short pause, which was delivered to us in this delay variable. If we're not at a value of 10, that means this segment should be off. So we'll just turn it off. And then we repeat this from the way you're seeing it on screen, top to bottom, turning on and off each of the LED segments based on the value that's in there. Now we come down to the actual program, the actual main loop, and it's really quite simple. We're going to create a value using our random library all the way up here, right here. And we will have that from a range of 0 to 10, 0 all segments off, 10 all segments on. And then we're going to pass, or call the function, I should say, passing it a 0.005 second, 5 millisecond delay for each one of these operations, turning an LED on or off, going through here one by one. Here's where we're sleeping. And this still gives a little bit of an animated display so that you can see a trend. Is the sound level going up or is it going down? And that's what this will do. It'll add a little animation to this, very briefly, but your eye can see it. So that's our 5 millisecond delay, and then the value that we created is a random number. And of course here you'd be pumping in a real value from whatever it is that you're trying to communicate. And then finally, I'm doing this every 50 milliseconds running through this routine. So that works out to about 20 times a second. And here again, back at the LED, you can kind of see the animation. When it starts to move up, you see that the lights are coming on, or the LEDs are coming on in a sequence. So that shows trend. It works better to mimic a lot of the analog displays that these sorts of things are replacing. So hopefully you get that. Again, now that it's in a subroutine or a function, you can utilize this in other programs quite simply. And you can add to it with more segments or take away if you got an 8-segment or a 6-segment bar graph display. The next one that I want to show you is what I'm calling the animated battery level indicator. So let's first go ahead and run that. And I'm going to flip this around because of my color sequence. Again, this one is red. Up here is blue. So imagine that would be like your full gauge at the very top, and at the bottom two on this particular bar graph are red. So that's your warning that you're almost out of power or the battery's almost dead. But typically what you'll see with modern day displays for battery level is it will animate through like this. It'll come through, it'll reset, climb up to its peak level, hold it for a little while, and then repeat. And you don't want that running real fast or anything because you don't want it to be distracting to the user. In fact, normally I would actually have this even slower yet running. The speed at which it animates is pretty good, but I would hold the on time for maybe as much as 20 seconds as opposed to, I think I'm holding it to just a few here. But this would be a great battery level or any other type of level indicator that you're trying to communicate to the user of your project. Back into the code, let's take a look at how that's handled. Same basic import of the libraries. We don't need random this time. We set up all our LED objects. Then here in our function, which I'm calling battery level gauge, we're passing it a delay. We'll have that down here so that we show our animation of the battery level rising. And then the value, which would be 0 to 10. 0 meaning, oh boy, and 10 meaning it's fully charged. Now in this case here, we're going to start again with the J side, which would be, in my case, this LED here on the bar graph display. It's kind of inverted now from what we were looking at before. I want to start with that one. If my value is 1, I'm going to turn that value on. And 1 meaning a very low battery level, right? Then we'll sleep for a short delay here. We can delay a little longer here because this isn't a high-speed message. It's just animating to make it visually appealing. Then we go to the next segment. If the value is 2, we'll turn that particular one on and delay again. And we repeat that all the way through. So it ends up just a nice animated display showing you the level of whatever you're trying to communicate. And here we're just calling out that function in our endless loop. We're calling up battery level gauge, this guy here. We will pass it our delay, in this case 150 milliseconds. And we're going to set it to a value of 10 so I could animate the whole thing. And of course, you'd be passing in the real value there. And then we'll sleep about 3 seconds, or precisely 3 seconds between the updates. And this is the area where you'd set it to a higher level to slow down that update. It doesn't need to happen every 3 seconds. 5, 10, 20 seconds, something a lot less. Before I wrap this up, I just wanted to give you an opportunity to see it in color. This camera seems to do a little better than the other one. And hopefully you can understand or appreciate how well this very simple device can communicate a quantity or a level, etc. Now, as I alluded to earlier, if you're using more than one bar graph or you don't have enough pins available, there are driver chips that will work with these bar graph displays. And I will be doing a video on that somewhere in the future. I've got quite a few ahead of me yet before I can come back around and go to the enhanced version or enhanced level of how to work with this bar graph display. I'd also like to mention I've got a whole bunch of other videos in this series, and you can either look for them on my YouTube channel or on the companion website, makingstuffwithchrisdehut.com. And I'll have links for that down below. I would really like to just thank you for spending some time with me today while I explain these bar graph displays. I think they're a great communications tool. As we've all seen with the other LED video, you can do so much with such a simple device with regard to communications. I sincerely hope you enjoyed this video. If you did, please subscribe, give me a like, and do that notification bell thingy. I guess it's somewhere up there or something. You click it and you get notified of new videos. Remember, it's all free to you. It doesn't cost you a penny, but it certainly helps the channel survive the YouTube algorithm, as they refer to it. Again, thanks very much for watching. I look forward to seeing you in the next video.